So here we have 2018, this is question 2, Leaving Cert Ordinary Level, and this question on complex numbers. So we're given Z1, this is what Z1 is, Z2, and Z3 is Z1 minus Z2. But we're asked to plot Z1, Z2, and Z3 on the Argand diagram, and I'm just after drawing it there. So this is the imaginary axis. So a complex number has two parts, a real part and an imaginary part. But I think the first thing we should do is work out actually what Z3 is. So Z3 is Z1 minus Z2. So Z1 is minus 2 plus 3i, and that's minus Z2. So minus 3 minus 2i. So we have to minus everything in our second bracket, so that'll be the first will just stay the same, and that's minus 3, so that'll be plus 3, and minus 2, so that'll be plus 2i. And then I'm going to underline or highlight our real parts. So this is a real part, that's a real part, so the real parts are the parts that don't have an i attached to them. So minus 2 and 3 gives us 1, 3i and 2i, so that will give us 5i. So this is what Z3 is, and so then I'm going to just label each of them. So Z1 is minus 2 plus 3i, so this is the real part and this is the imaginary part. So the real parts, we're going minus 2 on our real axis, so the real axis is the horizontal axis, and then we're going 3i on the imaginary axis. So minus 2 on the real axis and then 3i on the imaginary axis. So this is Z1, and then Z2 is minus 3 minus 2i. So across minus 3 and then minus 2i. So it's actually going to be, I didn't leave myself much space. So this here is Z2, and then Z3 is 1 plus 5i. So across 1 and then up 5, so this is Z3. So then it says investigate. So we're asked to investigate if the modulus of Z3 is equal to the modulus of Z1 plus the modulus of Z2. So the modulus is the distance from the origin. So say if we had a complex number a plus bi, so I'll just say this is a plus bi. The distance from the origin here, we'll call it or. But we can make a right angle triangle, and it's went across a on the real axis and up b on the vertical axis. So the modulus, or, well, we could use Pythagoras, say or squared is a squared plus b squared. But if we just wanted or, we could get the square root of a squared plus b squared. So in general terms, if we have a complex number a plus bi, the modulus of that is going to be the square root of a squared plus b squared. So we want to get the modulus of Z3. Well, Z3 is 1 plus 5i. So the modulus of Z3 will be the square root of 1 squared plus 5 squared. So the modulus of Z3 will be equal to 1 plus 25, which is equal to 26. So now I have to get the modulus of Z1 and Z2. So Z1 is minus 2 plus 3i. So the modulus of Z1 is this modulus, so minus 2 squared plus 3 squared. So that gives me, so minus 2 squared will be 4, 3 squared is going to be 9, so that will give me the square root of 13. And then if I want to get what Z2, the modulus of that is, so Z2 is minus 3 minus 2i, so the modulus of Z2 is a square root of minus 3 squared plus minus 2 squared. So minus 3 squared is 9, 2 squared is 4, minus 2 squared is 4. So that gives me the square root of 13. But so I got that Z3, so if I want to investigate if, so I got Z3 is equal to Z1 plus Z2. So I want to see if the modulus of Z3 is the modulus of Z1 plus the modulus of Z2. Well, Z3, when I got the modulus of that, I got root 26, and then when I add Z1, which is root 13, and Z2, which is root 13 together, I get 2 root 13, but the square root 26 is not equal to 2 root 13. So I would say Z3 is not equal to Z1 plus Z2. So the modulus, they're not equal. So the modulus of Z3 is not equal to the modulus of Z1 plus Z2. So that just means that sign there means not equal to. And then the next part, we're told another Z4. So Z4 is equal to Z1 over Z2, and we're asked to write Z4 in the form x plus yi. So Z1 is minus 2 plus 3i, Z2 is minus 3 minus 2i, so Z4 is going to be minus 2 plus 3i minus 3 minus 2i. So now I have one complex number divided by another complex number. So this is an example of division with complex numbers. So the aim of this, I want it in the form x plus yi. So I don't want to have a complex part on the bottom. And one way I can get rid of the complex part on the bottom, the i's on the bottom, is if I multiply this by its conjugate. If I multiply something by its conjugate, I cancel out the imaginary parts. So say if we say z is minus 3 minus 2i, well, the symbol for the conjugate is just a line overhead, so that's the conjugate, so we just change the sign in front of the imaginary part, so it'll be minus 3 plus 2i. But we can't just multiply the bottom of our fraction by something. We have to multiply bottom and top, so it's just the same as multiplying it by 1. So we're going to multiply top and bottom by the conjugate of the bottom. So minus 3 plus 2i, minus 3 plus 2i. So I'm just going to bring this down here. So that's minus 2 plus 3i by minus 3 plus 2i, and then minus 3 minus 2i by minus 3 plus 2i. So the minus 2 by my second bracket, and then 3i by my second bracket. So minus 2 by minus 3 plus 2i plus 3i by minus 3 plus 2i. And then my minus 3 by my second bracket and my minus 2i by my second bracket. So minus 3 by minus 3 plus 2i, and then minus 2i by minus 3 plus 2i. So now I just have to work with this. So I have minus 2 minus 3, so I get 6. Minus 2 plus 2i, so that would be minus 4i. 3i minus 3, so that would be minus 9i. So 3i and 2i is 6i squared. So then I have minus 3 minus 3, so that's 9. Minus 3 by 2i is minus 6i. Minus 2i by minus 3 is plus 6i. And this by this gives me minus 4i squared. So now I have to simplify this, and I also have to remember that I squared is equal to minus 1. So wherever I have an I squared, I have to sub in minus 1. So firstly, I have 6, so I have minus 4i minus 9i, so that'll be minus 13i. And where I have this I squared, I'm going to sub in minus 1. And then I have minus 6i plus 6i, so that cancels. And then 9 minus 4, so in place of the I squared, I'm going to sub in minus 1. So now I have 6, and then that's going to be minus 6, so that's just going to be 0. So I have, so that'll be 0 minus 13, so I'm just going to put in the 0, so then I'll have my real part in. And then that's 9 minus, so minus 4, so that will be 9 plus 4, so that will be 13. So then I have to divide my real and my imaginary part by the bottom, so that will be 0 over 13 minus 13 over 13i. So then that will be anything, 0 divided by anything will just be 0, and then 13, that'll be minus I. So my answer is 0 minus I, and that is in the form, they wanted it in the form x plus yi, where x and y are real numbers, and 0, and so I can write that as 0 minus plus, or it's minus, so I can write that as 0 minus 1i. So 0 and minus 1 are real numbers, so that is my answer for that question.